Good morning. This video is for my Tuesday-Thursday Math 161 students. This week we are working on 2.6, but before spring break, there were a couple examples in 2.5 that I didn't get to go over. So those I moved to this week's Alex homework, and I do have a page looking just like this on your second exam. So I'm going to make the first example for this week to be this page right here. I'm going to post the blank ones on Canvas so that you can print it out and work on it, but feel free to just write this down on a separate sheet of paper if you want to. But after watching this video where I go over all these parts, A through I. Oh, I found the typo here. At least 2 points on each curve. After watching this video and learning how to do all these parts, I will ask you to submit a classwork. And the classwork is also posted on Canvas. And let me show you that paper right here. It's called Graphing Rational Functions Classwork Problem. It looks almost like the one that we're about to go over together, but it's got 9 problems for you to try, finding all these asymptotes. Sometimes you're going to have to say none if you don't have a certain type of asymptote, finding domain and range, but it's exactly like, even this typo is exactly like the page that I'm going to go over as an example. Okay, so this is going to be your first assignment. I'm thinking this video will be about like less than 30 minutes for me to go over this one page with you, okay? All right, so let's start. Graph the rational function by completing parts A through I. And I know for our class you are allowed to use your graphing calculator, but I will ask you to find all these parts of this graph first, in addition to giving me a good graph. So let's find everything. Find A. Find the vertical asymptote. Now guys, 1 second. Let me put this piece of paper under here. Find the vertical asymptote. It's a great review. We talked about vertical asymptotes before spring break. Remember how to find these. Vertical asymptotes are when denominator equals 0. Okay, so the denominator of this rational function is x minus 2, right? So set, let me focus button one more time. Set x minus 2 equals 0. And then add 2 to both sides. We found that the vertical asymptote for this function is at x equals positive 2. So let's graph this. Let's graph this on this paper, right, on this graph right here. A vertical line that goes through 2 on the x-axis. There we go, we got this. Okay, so that's how you find the vertical asymptote. Let's look at the next one, the horizontal asymptote. Now remember we did this by 3 different cases, okay? In order for you to find the horizontal asymptote in our class, we looked at the degree of the numerator and the degree of the denominator. So take a look. Degree of the numerator is 4 minus 3x. That's to the first power, right? X to the first power. So degree of the numerator is 1. And degree of the denominator, it just says x minus 2. So x to the first power again. So notice that n is 1 and m is 1. They are the same. When n equals m, this is one of the cases. I hope you have the notes from before break. Let me find it because I just did it with my my Monday, Wednesday class yesterday. Gosh. Well, I can't find it, but, well, let me remind you. If they are the same, then what do? You simply take the ratio of their leading coefficients, okay? So quick example of a horizontal asymptote. I'm about to make up another function over here, okay, a random one. So remember, if you have g of x equals 5x squared plus 7 over 6x squared minus 3. And again, the degree of the numerator and the denominators are both 2. This is another example where n equals m, right? N is 2 and m is 2. And if you have that case, remember the horizontal asymptote is at y equals the ratio of their leading coefficients. And the leading coefficient is 5 on the numerator and 6 in the denominator. So the horizontal asymptote for this random example that I just randomly came up with is y equals 5 over 6. Now, that's something that we did before break, but I wanted to show you a case that was already kind of in order, standard form. Because do you notice that very often, take a look, a lot of people tell me that the leading coefficient is 4 on the numerator. Is that true? No. Leading coefficient is actually negative 3. So if you want to rewrite this, this will be negative 3x plus 4, switching these to order, over, well, the bottom is fine. Well, that's just going to be 1x minus 2, right? So the horizontal asymptote in this case is going to be the ratio of their leading coefficients. And what are their leading coefficients? The numerator is negative 3 and the denominator is 1. So the horizontal asymptote is at y equals negative 3 over 1, which is just negative 3. Okay? The one that I give you for your classwork is also written in a way that the numerator is actually switched in order. So you just have to look very carefully. Very often people tell me y equals positive 4, okay? It's not y equals 4, okay? Because the leading coefficient is negative 3 on the numerator. I think I'm going to erase this because I don't want to confuse people. All right, so let's go ahead and graph that y equals negative 3, a horizontal line going through negative 3 on the y-axis. Let me use a dotted line. There we go. Okay, now I can't remember if we talked about oblique or Slant Asymptote before break, but well, I'll go over as if we never really talked about. The Slant Asymptote only exists when n is equal to m plus 1. I wrote it this way because the exact, I think you still have the notes with you. We only have the slant asymptote when the degree of the numerator is exactly 1 bigger than the degree of the denominator. But take a look. N is 1 and m is 1. They are the same, right? They're the same. We're not going to have a slant asymptote here. We're not going to have a slant asymptote here. Why not? Let me still make up some examples and show you when we will have slant asymptotes. I'm grabbing a piece of paper, okay? So right, when do we have a slant asymptote? All right, let me give you some examples when we have this slant asymptote. F of x equals something like 5x to the 7th power minus 5 divided by 4x to the 6th power plus 3. Oblique asymptote, we're going to have one. Let's take a look. What is the degree of the numerator? It's 7, right? What about the degree of the denominator? 6. Notice how 7 is exactly 1 bigger than 6. So yes, we're going to have one, okay? Another one. What if you have something like g of x equals negative 4x cubed plus 5x to the 8th power. I'm just making up a random one. 5x squared minus 6x to the 7th. All right. And I know I wrote these not in order, but what is the degree of the numerator? Is it 3? No, the degree is 8, right? And degree of the denominator is 7. Now notice 8 is exactly 1 bigger than 7, right? So in this case, yes, we're going to have a slant asymptote or oblique asymptote. A last one, let me make it so that it doesn't have it. H of x equals x minus 5 over x squared plus 7x plus 6. Just completely random. All right. Now, what is the degree of the numerator? It's just x to the first power, right? So the degree of the numerator is 1. What about the degree of the denominator? 2. Now, okay, 2 is bigger than 1 by exactly 1, but notice how the bottom is bigger this time. In order for you to have a slant asymptote, the top has to be bigger by 1. 7, 6, 8, 7, not 1, 2. If it was 2 on top and 1 in the bottom, yes, you would have had it. But for this case, no, you're not going to have one. Okay, so I hope this explains when we will have slant asymptote. So only if the numerator has exactly, it has a degree that is exactly 1 bigger than the denominator degree, okay? So here, because the degrees were exactly the same, we're not going to have a slant asymptote. I will find an example or make up another example to show you how to find the slant or oblique asymptote when we find out that, that the function has it. Now, let's find the x and y intercept, and I'm going to do these algebraically. I'm going to find the y-intercept first. This is going to be the easier one. The y-intercept is when x value is equal to 0, right? So, I'm going to plug in 0 into this function. The function was 4 minus 3x over, so y equals 4 minus 3 times 0 over x minus 2, so 0 minus 2. 0 minus 2. So let's see what that is. This is 4 minus 0 over 0 minus 2. So we have a y-intercept at y equals negative 2. So we're going to plot this point 0, negative 2 on the y-axis, okay? So that's how you find the y-intercept. Just plug in x equals 0. So y-axis, we are going to have a point right here. Okay. Now let's find the x-intercept, okay? So watch carefully. X-intercept is when y value is equal to 0, right? So this time, instead of plugging 0 into x's, I'm going to set the function equal to 0. So 0 equals 4 minus 3x over x minus 2. Now, a fraction is 0 when the numerator is 0, but I want to do something that I will do on part E. What I will do to both sides is I'm going to multiply both sides by x minus 2, okay? I'm going to multiply both sides by x minus 2. Why? I want to cancel out this denominator. That's gone now. But what is x minus 2 times 0? In fact, anything times 0, that will just turn into 0, right? So we get 0 equals 4 minus 3x. Okay, let's solve this for x. I'll just add 3x to both sides. I will get 3x equals 4. If I divide both sides by 3, work it right here. X-intercept is at 4 over 3. All right. Now I'm going to plot this. 4 over 3 is approximately 1.33333. So I'll do my best. 1 to the right, and I'll probably just plot something that's in between 1 and 2, something like that. That looks good. Okay. So the x-intercept is at 4/3 and 0. And now, later on, and we will read this, we'll read that we're gonna just need to plot at least 2 points on each curve. And I do have 2 points here on this left side. So I'm done. Hold on. Oh. Oh, allergy. But I'll come back and graph this later. But I do have 2 points that I can use to graph this side. All right. Go down to part E. Now this one, I do want you to show work. Okay? You don't just say, oh, it's not going to cross it. Because the thing is, your rational function will never cross the vertical asymptote. Because in order for it to cross it, we have to actually touch it, right? Touch that vertical asymptote. But if x is 2, what happened to the function? The denominator will be 0. The function will be undefined. So, you know how we found this vertical asymptote, we will never be able to cross the vertical asymptote. And in fact, we will use that fact that x will never be equal to 2 to find the domain of this. But then the thing is, horizontal asymptote is a little weird thing. Horizontal asymptote only talks about the right and left end behavior of the graph. So it really doesn't say anything about what the graph can do in the middle of it. It may cross. So what I want you to do on part E is I want you to show me algebraically that it's not, or it's not going to cross that horizontal asymptote. So I'll write down the horizontal asymptote that you found on part B. What was it? Y equals -3, right? Now what I'm going to do is I'm going to plug in y equals -3 into the function and see if that equation is solvable. Let me try. So -3 equals 4 minus 3x. That's getting divided by x minus 2, right? Now, what did I do to both sides above here? It was a very similar type of equation, right? I'm going to multiply both sides by x minus 2. Take a look. I'm multiplying both sides by x minus 2. If I do that, the left side I will have to distribute. Now, the case up here, I didn't have to distribute the 0 because that times 0 is just going to be 0. But I have to distribute the -3 in this case. So the left side will be -3x, -2 times -3 plus 6. And that equals, now what happened to this denominator? X minus 2 cancels out, leaving me with only 4 minus 3x. All right. Now notice something for me. They both have, what on both sides? They both have -3x and -3x. You know what? I'm going to add 3x to both sides. If I add 3x to both sides, what will happen? The -3x cancels out, -3x cancels out, and we are left with 6 equals 4. Now, is that true? No, never. So what we just showed is there is no solution that will make this a rational function to have a y value of -3. So this is telling me, this is enough for you to just point it and say, no, f of x does not cross the horizontal asymptote which is y equals -3. It's not going to cross the horizontal asymptote of y equals -3 because you saw if you assume that y is -3 and try to solve for x, we get nonsense. So show me this work. Don't just say, oh, it's going to get really close. It's just never going to touch it. No, you have to show me with this work that it's not going to cross it. Alrighty, let's find the domain and range. Now for domain, we do know that x can't be equal to 2, right? X can't be equal to 2. What am I using? I'm using the vertical asymptote. Using our vertical asymptote, we know x can't be equal to 2. So how do I write that in interval notation? From -infinity to +2, union, I jump when we see that 2, and then start back at 2 and go all the way to positive infinity. So that's the domain of this rational function. Okay? All right, range. Didn't we just prove on part E that this will never cross y equals -3? So the range is going to be everything except for -3. All right, so let's write that. And then this is using our horizontal asymptote. Using horizontal asymptote, the range is going to be from -infinity to what number? -3 union, and start back in -3 and go all the way to positive infinity. Okay, now the end behavior. And this is just using the horizontal asymptote. This is using our horizontal asymptote of y equals -3. And I gotta find this, the definition page that I used. Hold on. Let me put my calculator over here so that I can, okay, here we go. I found it. All right, let's read what horizontal asymptote is real quick. Okay, from last week. Where should I read? Okay, here, right here. The line y equals b is a horizontal asymptote of the graph of a function f. Now read this part very carefully. If the value of f approaches b as x value increase or decrease without bound. And this is exactly what I'm asking for this end behavior. If x gets really, really big, so as we are going to the right side of the graph, keep on going to the right, the f of x will approach this horizontal asymptote value of -3. And as x approaches -infinity, so as we are going to the left side of this graph, f of x will approach -3. Okay? I'm going to use that to graph at least one piece of my graph where I have 2 points already. So take a look. I'm going to connect these two, but as x values gets really, really, really small, so as I'm going to the left end of, or left extreme of this graph, we're going to get really, really close to this horizontal asymptote of y equals what? -3. That's what the end behavior is saying. It's not going to go cross it and go down. And we just show that it's not going to cross it. So it's going to go down and get really, really close to this horizontal asymptote. And remember the vertical asymptote. That's the line where my graph will go either up to positive infinity or -infinity. So as I go really close to this vertical asymptote of x equals 2, I'm just going to go straight up. I'm going to try to get really close, but I'm really just going up that way. So that's one piece. And now I need to figure out another piece, the second curve. Now, notice I have a graph to the left of my vertical asymptote. I need something to the right side of it. So, oh, bless me. Look, I got 2 points at 0 and like 1.3 repeating. Let me plug in some random points that are to the right side of the vertical asymptote. I'm gonna plug in, I don't know, maybe like, I don't know, I'm gonna be random and plug in 8. All right, let me plug in 8 into my function. If I plug in 8 into my function just so that I can plot 2 more points, I'm finding what's f of 8. F of 8 is 4 minus 3 times 8 over 8 minus 2. Oh, I'm getting lazy. I'm going to go ahead and plug this into my little scientific calculator. 4 minus 3 times 8. 8 minus 2. It's an ugly little point. But what's that in decimal? About -3.3333. So, okay, I wasn't too lucky. I got a point that is 8, comma, -3.3 repeating. I'm just going to plot that. Why not? Go 8 to the right, down 3, a little more. Ooh, do you see? You see that we're getting really close to that line right there, but we are below it. All right, I need at least one more. Hopefully I'm lucky this time. How about I plug in 4 this time? F of 4. That's going to be 4 minus 3 times 4 over 4 minus 2 you know what I'm doing? I'm just plugging in these random x values into my function where I'm pointing to get the y value. But now look, you guys have all that, have that graphing calculator. So use that if you want to just find extra points. I didn't bring my graphing calculator home with me. I should look for one. Okay, so let me type that in. 4 minus 3 times 4 divided by 4 minus 2. Yay, that was a nice point. So I'm going to plot 4, negative 4. 4, negative 4. All right, 4 to the right, down 4, E. Now I kind of want another one here. Why don't I just do that real quick? I'm going to plug in 3 real quick, okay? 3. So if I plug in 3, 4 minus 3 times 3 over 3 minus 2, that got me negative 5. So I have another point at 3, negative 5. 3 to the right, down 5. Okay, probably good enough. And then I'm going to connect these dots, okay? So as I go to the right side, I will get really, really close to my horizontal asymptote. I'm just not allowed to cross it. And as I go to the left side, I'm not allowed to cross that vertical asymptote, so I'm just going to go straight down. So that's how I want you to graph your rational functions. Watch this. I know you watch this carefully, right? Hold on, let me show you the whole page. So it took me about like 26 minutes to go through these. I don't have a scanner at home, so I don't think I'm gonna scan this and post it on Canvas. So I know you took some notes. So use this, please. Use this to try your. Where's the classwork? Oh, right here. Classwork right here. And please don't wait until Sunday. I know the due date is Sunday just because I want you to have some time, but you know, the sooner you submit it, I can give you feedback. If anything is wrong, I can ask you to fix it. You can keep on doing that until you get 9 out of 9. So I'll be looking forward to grading some of your paper this afternoon. Please try this classwork after watching this first video. Submit it and come back for more examples, okay? I'm probably going to have about 2 more videos and 2 more problems for you to try this week. All right, thank you.